might put one on the upcoming test. So it says, the square root of negative 8 is equal to what? So aren't we just simplifying it? It's just a fancy way of wording it. Now, once again, guys, we have to be able to see things in different wording and still know what we're doing. Did everybody understand that we're just simplifying this? So remember, the square root of negative 8, isn't that the same thing as the square root of negative 1 times 8, everybody?
Yes.
Now we break down 8. 4 times 2, 4 breaks down into 2 and 2. Now we're pulling out groups of 2. I had somebody say this to me. So what if there was 2 3s? We can't pull those out because they're not 2s, but they were misunderstanding. Isn't it groups of 2? So if we have 2 smiley faces, can't they leave? Yeah, okay. So we have 2 2s. They can leave the house. Don't double dip. The 4 is not there. Can we pull out that 2? No. Do we always pull out a negative? Yeah. What does it become when you pull it out?
Positive.
I, right? So we have 2I, so we have 2 from those 2 2s, and I from the negative 1. Left underneath was the square root of 2. Okay? I have so many people getting this one wrong, and I can't quite figure out why. So do you have questions? Yeah.
Does it have to be in 2I or just I2?
Great question. Brendan asked me to say I2 square root of 2. I think that's not a very pretty answer. Same thing, technically, so I might mark off a little bit, just because we would write 2I. But it is technically the same thing. Yeah, good question. I like that you asked it, because you're right. Absolutely. We would write it like this instead. But this is technically the same thing, but they would mark it considered wrong. Yes.
So
not wrong, but...
Say for a non-factor.
Ooh, great question. I actually was going to bring that one up. So, you guys, look with me. I saw so many people get this wrong. Let's change the problem. Let's say I said, what's the square root of negative 7? Is there any factors of 7? No. So that's still negative 1 times 7, right? Yeah. So don't we pull out an I?
Yeah.
On the outside, and then left was the square root of 7. Like that. Okay, so make sure, this is also one thing I'm seeing. I'm seeing people go like this. 2 square roots of 2I. They're keeping the I underneath, but you pulled it out, and that's why it became I. So don't do that.
You can't have a square root.
Yeah, you can't have a square root of an I. Absolutely true. Okay, questions. Let's get to what we're doing today. So guys, this unit, yesterday we focused in on exponentials. We're kind of all over the place because it's called other functions. So we're just going to be focusing in on other functions. So today we're going to be graphing, so yesterday we did exponential functions, today we're going to be graphing radical functions. So we're going to first start out with square root functions. So we have f of x is equal to the square root of x. This is the parent function, non-shifted function. There's nothing added with x, there's nothing added on the outside. So this is the most basic non-shifted square root function, called the parent function. So this is what it looks like. It kind of looks like a sideways parabola, but only the top half. Now, notice something. It starts at 0, 0. Does everybody see how our starting point's at 0, 0?
Yes.
Okay? And then if we get this pattern, which we'll talk about a little bit later, but if we plug in 1, what's the square root of 1? 1. So we plug in 1, we get 1. Now, if we plug in 4, what's the square root of 4? 2. And then so on, okay? So with that being said, we'll do this one. If we plug in 9, what's the square root of 9? 3. So there's this actual pattern that happens with square root functions that I actually will point out a little bit later. So there's an up 1 over 1, up 1 over 3, up 1 over 5. So there's a 1, 3, 5 pattern that always happens with square root functions.
1, 3, 5.
Now, everybody, I want you to type it into your calculator. Go. Hit y equals, type in the square root of x. So looking at that, now I want you to go to your table of values. So second table. Now look at your negatives. Don't they all say error? Like look at your negative x values. They say error because look, does our function even contain any negatives in this one? No. So your graph will tell you. Now look, what's your function at 1?
0.
What's your function at 1? 1. What's your function at 4?
2.
What's your function at 9? So, anyways, just different ways of looking at it. Okay, let's talk domain and range. So, domain is x values. At what x value does our function start? 0, and it's growing to positive infinity. Range is y values. So, what's our lowest y value? 0, and it's growing this way to positive infinity. Okay, Here is the equation to a shifted square root function. Now guess what? Shifting works the same way. So remember yesterday when we were shifting exponentials. Wasn't anything added with x or shift left and right? And we always went opposite. Well, that's going to work the same for square root functions. And then remember back to exponential functions. Anything added on the outside was our shift up and down. Well, that works the same for square root functions. So once you know how to shift one function, you know how to shift all. So a couple things to know. The a value in front of the square root, what's being multiplied in front of the square root, that's called an acceleration. So an acceleration is how much it's growing, rate of growth. So acceleration. And then x minus h. Guys, does everybody, first hour was not quite getting this. Do you see how this is added underneath with x?
Yes.
That's our shift left and right. Just like with exponentials, wasn't it anything added with x was our shift left and right?
So is it the same as, like, if it's a negative, it goes right?
Yeah. Yep. So it works the same for all functions. So yep, if this was x minus 3, we'd be going right 3. Okay? So that's our shift left and right, and you always go the opposite. Now look, isn't the plus k added on the outside of the function? So that's your shift up and down, and your sign stays the same. So this said plus 3, we would shift it up 3. You've got to get that down. It works the same for all functions. Are we ready to graph these?
Yes.
Okay. Take a picture of this if you'd like it. There are a couple different ways we can graph quadratics. First of all, some people first hour were getting their panties in too much of a bunch over this. If you can't figure out how to do this, just plot some points. Plot a bunch of XY points. We can always refer back to that. Here's how I like to graph it because it's quicker. So first of all, the first thing I do is find a new starting point. So we aren't at the origin anymore. We've now started somewhere new if it's been shifted, right? So you find your new starting point by saying, where am I shifting left and right? Where am I shifting up and down? Now, every single one of you have to be able to do that step. Then second, from there, I always go up or down my A value. So I go up or down A, and then there's a 1, 3, 5, 7 pattern that happens. So you'll go up A over 1, up A over 3, up A over 5, up A over 7. Does that make sense? So if it's negative A, we'll go down A over 1, down A over 3, down A over 5, down A over 7. If you don't like doing that, type it into your function and plot the points that you're given. Okay? So either way will work. So let's just practice. Stay with me so we can go through this quickly. Pay very close attention to little details. First step we do, identify your shift left and right, up and down. Every single one of you have to be able to do this without a calculator.
Right 3, down 4.
We're going to right 3 and down 4. Does anybody have any questions on why? Okay, I'm going to plot that. So origin, I went right 3, down 4. Boom. Questions on that? There's my new starting point. So then this is how I go about doing this next part, because I don't want to have to type it into my function. However, it's never a bad thing to do that. What's my A value? Don't say 0.
1.
So my A value is 1. So we're going to go up, and it's positive 1. So we're going up 1
Over 1.
over 1. We always go up or down your A value, so you go up 1 again over 3. Then up 1 over 5. And when I say over, no matter what, you're always going over to the right. So from my new starting point, does everybody see the 1, 3, 5 pattern? Ding, ding, ding. Do you see it? Okay, so I'm going to do it like that. Up 1 over 1 from my new starting point. From here, up 1 over 1, 2, 3. Then up 1 over 1, 2, 3, 4, 5, so it's off the graph. All right, let's list out domain and range. So domain is x values. How far left and right? So take your pencil. What x value does it start at? Boom. 3. It started right at 3, so it includes 3, and it's growing that way to positive 3. Range is y value. Shift your eyes. How far up and down? Boom. Negative 4, and it's growing to positive infinity. So pretty simple, right, guys? Now you could even check me by typing it into your calculator. Y equals, type it in, and you could check my xy points. So it's going to say error for all of these xy points over here because there's no function, right? But then after that, it'll give you these same points that I plotted. Okay. Let's do another one. So let's determine our shift left and right, up and down.
Right 1.
Right 1, any up and down?
Nope.
So no up or down. Okay. So we're going to right 1. So on here, right 1. Boom. There's my new starting point.
Yeah.
Is everybody comfortable with that?
Yeah.
What's my A value? 2, right? So we're going to be going, because it's positive 2, we'll be going up 2 over
0.
1. It's a 1, 3, 5 pattern.
Yeah.
Up 2 over
Perfect.
3. Up 2 over 5. Okay, so let's do that. From my new starting point, up 2 over 1.
Up 2.
Up 2 over 1, 2, 3. Up 2 over 1, 2, 3, 4, and 5. Now look at that. I've drawn in my square root function. Now look at, isn't the acceleration 2? So wasn't it getting larger quicker?
Yeah.
Yeah. Okay, so it looks a little bit more stretched out. Domains x values. What x value? Boom. 1, and it's growing to positive infinity, right? Range is y values. Now, not x, y. What y value? 0 to... Okay, one more. Now, guys, let's say you didn't like the 1, 3, 5 thing, or let's say you forgot. Couldn't you just, once again, type that in your calculator, go to the table, and plot those points? There's going to be points in between that are decimals, but I just look for the whole number points. Does that make sense? Because there's all these points in between, but I just find the whole number points. Okay. Last one. Okay, because it looks a little different. Where's my shift left and right?
0.
No shift left and right, right?
Right.
Everybody?
Right.
So there is a shift up
24.
4. So no shift left and right, but we are up 4. There's my new starting point. Then you guys go up or down your A value. My A value is negative 3. So we'll be going down 3 over 1, 1, 3, 5, down 3 over 3, down 3 over 5. We always go to the right, no matter what with these. So we're going down 3, down 1, 2, 3, over 1, down 1, 2, 3, over 1, 2, 3, down 1, 2, 3, over 1, 2, 3, 4, and 5.
Oh.
Okay, if you don't believe me, type that into your calculator right up here, and I promise you'll get these same x, y points. Okay, domains x, where's x, x, x? Don't focus on how far up or down. Boom, what x value?
0.
0, and it's growing to
Negative.
no x values. Isn't this growing this way? Positive infinity. Now range is y values. 4 to negative infinity. Which one do we put first?
Negative infinity because it's smaller.
Negative infinity up to 4.
In a bracket.
In the parentheses.
Okay, questions? You ready to go? Okay, use your graphing paper. Go. 1 through 6. Make sure you state the domain and range. Okay, so now I'm going to teach you how to solve a square root equation. There's 2 different ways you can solve a square root equation. You can either go about it algebraically or graphically. Both are pretty simple. Most of my students first hour said graphing is the easiest, and they just graphed them. So watch both, see whatever you like, and then however you like to do it, it's your way. So here's how we would go about solving the square root function algebraically. Now, you have to understand a couple things. To solve a square root function, you have to isolate the radical. So this is a radical. Do you see how it's isolated? Nothing is added to it, nothing subtracted to it. Okay, it's isolated. Now we have to undo the radical. What undoes the square root?
Square.
Square. So you've got to do that to both sides of the equation. So our root then cancels out with our power, and on the left leaving us with x minus 3. That's equal to 2 squared, which is 4. Then from there, it's just algebra. To get x along, we'll algebraically add 3. Add 3. X is equal to 7. That's one way of doing it. Now, understand something. If you want to do it graphing, that is great. Let me show you something. So you have to understand something. We want to know when this function is equal to this function. So it's 2 separate functions we're looking at. So we have a square root function, the square root of x minus 3. So we know it'd be going to right 3, right? So I'll show you how to use your calculator in just a second. So right 3, up 1 over 1. So I just want to show you what it looks like real quick. So we have this square root function. Now understand, this is a different function. That's just a line at y is equal to 2. So that's a straight line at y is equal to 2. So that would be a straight line like this. So you want to know where are those functions equal. So isn't that where they intersect? Boom, right there at 7. Do you see how they intersect at 7? Now, your calculator will do it for you. So pull it up. type in, go to y equals, and we have two equations, so we have the square root of x minus 3. You got to type it in right, though. Is the 3 added underneath the root? On this one, yes. Then our other function was 2, right? So I hit 2. Now I hit graph. So it's going to show you, there's my square root function, there's my line. Now we want to know where they intersect. Don't try to count. You might be off. To the human eye, it might be a little bit hard to do. So you'll do second trace, go to intersect. Oops. Okay, now right here it's saying first curve. We need to make sure we're on one of the functions. So you're going to scroll with your arrow. Because right now you're at x is equal to 1. Is there a function at 1? Look, on this square root function, is there anything at 1? No, so let's scroll till we're on our function. So look, do you see how now I can see it's on my function, everybody?
Yep.
So I hit enter. Then second curve is the straight line. So it'll automatically do that one for you. Hit enter again. It'll say guess, hit enter again. And look what we get. X is equal to 7. Does everybody see? Awesome. Oh, you found how to switch it? Wait, you found what? Oh, awesome. Yeah. Does everybody see how it's entered, how to do it with your calculator? Okay, now, I want you to think about something. What if, totally different problem, I'm going to erase this. Look up here so that you understand something. What if I said solve by graphing, and you had a square root function that looked like you graphed it, one looked like this, and the other looked like this. Do they ever intersect? No, so this is when we would say no solution. Does that make sense, everybody? Okay, awesome. So do problems. Oh, wait. Maybe I should do this one. Do you feel like you want me to do this one?
Yeah.
Okay, so we have a square root function and a square root function. Is the radical isolated? Is it? There's nothing added to it, nothing subtracted to it. So yes, it's isolated. Over here, nothing added to the radical, nothing subtracted to the radical. So it's isolated. So I'm going to go through and solve this algebraically. So I need to undo the square, right? Square root. So we square it. Well, we got to do that to both sides. So on the left, our root cancels out our power, leaving us with x minus 1. On the right, guess what happens as well? Root cancels out power, which is awesome, because now we have this linear function and it's pretty easy to solve, right? So we'll combine our x's, so we would add x. So we have 2x minus 1 is equal to 4, so we would add 1. So we have 2x is equal to 5, divide by 2. So we get x is equal to 5 halves. Now, if you were to solve this one by graphing, you would have graphed them, you would have seen where they intersect, it would have gave you a decimal, which is great. You change it back to a fraction, and you'd be at the same spot. Does that make sense, everybody? Okay. So do these problems, 7 through 9. So let's go about solving this one. Look with me, really important. So I always opt for algebra, but you need to know something if you're one of those people. So let's go through this one algebraically. If we were going to solve for this one, don't we have a square root and a square root isolated?
Yes.
So we'd undo it by squaring both sides, right?
Yep.
So we have x minus 5 is equal to x minus 3.
Yep.
I'm sorry.
Solving for x, piece by piece, wouldn't we need to subtract x?
Yes.
So isn't that 0 minus 5 is equal to negative 3, right?
Right.
So isn't that negative 5 is equal to negative 3?
That's not true.
Is that a true statement?
No.
No, not a true statement, so there's no solution, okay? Now, what would have happened is we would have graphed these. One would have looked like this. The other would have looked, oh, sorry, not like that. Yep, like that. And one would have looked like this. Do they ever intersect? No.
They're parallel.
Now, they're parallel because their accelerations are the same. Does that make sense, everybody? Okay, so just keep that in mind. Okay, so now we're going to graph cube root functions. So this is what a cube root function looks like. Now notice if I cover up this, doesn't that kind of look like a square root function? But now the cube root function will come down and swing down on the other side, kind of like a snake. So the cube root function, f of x is equal to the cube root of x. The only way I'm going to have you graph these is first find the starting point, which with this one, it's at 0, 0. There's no shift left and right. There's no shift up and down. Then from there, I'm not going to have you learn a little trick. There is kind of one, but I'm just going to have you plot as many points that can fit on your graph to the right and as many points that can fit on your graph to the left. So you'll just type it into your calculator and find the whole number of points that fit on there. Does that make sense, everybody? Then we'll just plot some points. Graph it. So let's do one. So yeah, let's talk about this though. Domain is left and right. Isn't it going that way forever, that way forever?
Sure is.
So negative infinity to positive infinity, all real numbers. Isn't it also growing like this forever?
Yeah.
So all real numbers, all cube root functions will be domain and range all real numbers. Yes. Okay, so shifting of cube root function works the same as a square root function. So if you know how to shift a square root function, you know how to shift a cube root function. A is the acceleration. What's added with x underneath the radical, what's combined with x, with addition, is your shift left and right, you go opposite, and then the plus k is your shift up and down, and your sign stays the same. It works the same for all functions, so we're not learning anything new. Here's my example. Okay, so we have the cube root, 3 times the cube root of x minus 2. I do expect you to be able to do this part by hand. We're going right
2.
Right 2. Anything up and down?
No, 3.
Nope,
No,
right 2.
That's the acceleration, huh?
So there's my starting point. Now I want you all to type it into your calculator. Let me show you how. Okay, so you go, so let's get rid of this and this. Okay, so you hit, so we want the cube root, but first we need a 3 because our acceleration's 3. So 3. Now if you want to type in cube root, you have to hit math and down to the cube root, which is number 4. So we have the cube root, it was x minus 2. Was it underneath the radical? The x minus 2.
Yeah.
Then minus 2 was, yep. So you got to type it in right. Did everybody see that? Now I want the table of values for that, so I hit second table. Now we knew our starting point was at over 2 up 0, right?
Yeah.
So I'm going to find that. Over 2 up 0. So I'm going to find 2. Look, 2, 0. So I want a couple points below it. So below it and a couple points above it. So below it, let's find some whole number points. 1 and negative 3, right? So don't forget that. 1 and negative 3, and then also negative 6, negative 6. So I'm going to write those down so I don't forget. So it was 1 and negative 3. It was negative 6 and negative 6. So let's plot those points. So you go from the origin. If we're just plotting points, you always start at the origin. So we go over 1, down 1, 2, 3. We're going negative 6, negative 6. Down to here. So there's some points below. Now I want some above. So look on your table, tell me some more so I can plot them. 3, 3, and...
Is it just mirrored?
10, 6?
Hey, miss, is it just
10, 6. So we're going over 3 up 3. Oops, over 3. Sorry. Over to 3, right? From the origin. So over to 3 up to 3, right? Then we're going over to 10 up to 6. And look at that. We have our snake cube root function drawn out nice and pretty. It is mirrored, yes.
so like, cause like it goes down, this one goes left 1 and then down 3, but then it goes right 1.
Yeah, they are mirrored.
Okay.
Yeah.
That's how you can do it here?
Yes, just make sure you're really careful. It's just as easy to plot some points exact, you know what I mean?
Yeah.
Okay, any questions on that? Can you do it by yourself? Okay, I won't do this one then. Okay, so go do 11 through 13.
Yeah. Yeah.
Okay, so I'm going to do my examples off your worksheet to lighten your burden. Here we go. So read the instructions. It says, rewrite each function to make it easy to graph using transformation of its parent function. So we know every function that's been moved around is a transformation from the parent function. So it says then don't graph it, but describe the graph. So let's look at number 14. We have y is equal to the square root of 81x plus 162. So there's just a lot going on underneath that root, right? Now everything we've seen so far, there's never been anything multiplied in front of x, right? It's always just been x plus 3 or x minus 2. So we can actually fix that because we know how to factor. So we're going to simplify it just by focusing on this piece. We're going to simplify that down. So everybody, we have the square root still, but I'm going to ignore it for a minute. What's in common? Well, let's always factor out this because we want to make that 1. So we're going to factor out that value no matter what. So I'm factoring out 81. Now when you factored it out, go back to see what's left in your parentheses. Divide each term by what you factored out. Right? That's how factoring works. Stop acting like a crazy person, people. Okay, so what was left here though? X, right? X, right? Are you okay? No wonder you don't get it.
I'm totally getting. You're factoring out right now.
Then 162 divided by 81 plus 2. Now everybody look. From here, these are multiplication, right?
Right.
So think about it. Remember when we have the square root of 2 times the square root of 3? Because they're both under the square root, can't we pull them together and say that's the square root of 6?
Right.
So if you can pull them together, can't you split them apart? Yeah, so let's split it apart. This is the same thing as the square root of 81 times the square root of x plus 2. Isn't that the same thing? Are they both still under the square root?
Since when can you combine square root?
You always, with multiplication, you always can. Okay, what's the square root of 81? So we have 9 times by the square root of x plus 2. And now isn't it much prettier?
Oh, yeah.
Yeah, it's way prettier. So our final part will be to describe what our graph looks like. So we have an acceleration of 9, right? You have to describe it. And then are we going left 2? Isn't that what it should be left 2? So that would be our answer. Okay, let's do another one off the worksheet. Number 18. Now this time we're looking at a cube root function. So once again, there's a lot going on underneath that cube root. So we're going to hone in on that and simplify it. So we have the cube root. I'm going to ignore this stuff and put it in my final answer for a minute. So I'm always going to factor out that amount so we can make that a 1 in front of that. So I factor out 8. So then divide each term by what you factored out. Left is x minus 7, right? Now let's not forget what was, okay, let's actually keep going. So we can split it up and we know that's the cube root of 8 times by the cube root of x minus 7, right, everybody? What's the cube root of 8? 2. So we have 2 times the cube root of x minus 7. But now we can't forget in the original problem we had a negative. And the original problem we had plus 4.
Wait, how did you get 2 right there?
Because we took, good question, we took the cube root of 8, which is 2. So we have this new function. There's our answer. It's just now a lot prettier. We could graph that much easier than that. So our acceleration is negative 2. We're going to right 7.
Up 4.
And up 4.
Shouldn't you combine the negative 2 and 4?
Great question. You can't because this is multiplied to this. Good question.
Wait there for a second.
Okay, one more.
Wait.
Are you good?
Let me just write the equation.
Are you good? Do you need another example? Are you ready for me to let you just work?
Yes, give me. Yes.
Yes to letting you work or yes to another example?
Yes.
Okay, then I'm letting you work.
Oh, well, no,